first of all, who is the Java developer here? Okay, that's at least good. Who is familiar with AWS cloud provider? Okay, about a half. Who has tried like just writing Java, Lambda functions? Okay, several people, less and less. So let's see, there are reasons for that, why there are so few people doing this, but this is one of my jobs, just trying to change it. As I was introduced, my name is Vadym, and I have these two passions, Java and serverless. I'm one of the co-organizers of Java user group Bonn, where I live, and I'm also the AWS community builder in serverless category, talking about serverless in general, but especially about Java development. You can get in touch with me via different channels, and I blog quite a lot exactly about this point, this topic, just trying to find the ways. Basically, I'm working since 18 years for the same company called ip.labs, where we are writing software for design and purchasing the photo products. I started as a Java developer there, and I developed Java since the end of the last century, basically. We did a move to AWS cloud, and in the last years, I'm basically deal with cloud, and we are not doing too much Java on the cloud, but this is kind of my private topic, the research, how to put Java kind of back into this, especially AWS serverless stuff. So let's just paint a picture and just look into the Java, at least at the popularity of the Java as a programming language. And just doesn't matter what resource you will take, and there are so many different algorithms how you can measure it, number of repositories at GitHub, number of job postings related to Java, but in the end of the day, you will find out that Java belongs to the top 3 popular programming languages anyway. It's just mainly about these 3 JavaScript derivatives of it, Python and Java. Now let's look into the life of the AWS developer, serverless developer. And the thing is, now it's really cool, to be honest, because, for example, AWS has its own distribution, Amazon Corretto, they patch the stuff, and they support these long-term versions a bit longer than, for example, Oracle does. So this is Amazon Corretto. And now we have this last long-term version 21, which is supported since November last year, which came 2 months after it has been released. We needed to wait quite a long for Java 17 if it would look like it has been supported only since April 2023. So 1.5 years waiting time. It was really not a nice space, and we're asking how serious AWS is taking this, but they improved, and now the last long-term version was supported quite after it, and now Java increased the pace so that the long-term version will be released each 2 years and not 3 years. So this is the expectation for AWS. And if you look to the people behind this Amazon Corretto, you will see Amazon is taking Java really serious. James Gosling, no introduction needed. Alexei Shipelev worked for Red Hat on garbage collector, so many things. There are 2 Germans. I live in Germany, Volker Simonis and Roman Kenke, so the people working in compiler making things quicker. So this is something where I see, and Alexei Shipelev, I think, came even last year. So these are quite a good signs, and the innovation provided by AWS shows me that, we expect more. But basically, Java is a very fast and mature programming language, but serverless adoption of it looks like this. Here on the left and right side, basically, you can see what programming languages are used to write Lambda functions. The same report of Datadog, but one from 3 years ago, and the second one from the last year. And you see Java is number 3, which corresponds, but you see the gap. It has been maybe 4% of Lambda function written in Java 3 years ago. Now it's 10%, and it doesn't correspond to popularity. So we see that Java kind of struggles on this serverless space. There are reasons for that, why all these Pythons or Node.js, TypeScript, JavaScript, they are much more popular. So basically, developers, we are really happy. Java is a wonderful programming language, wonderful community, so many open source projects, Spring, Quarkus, Micronauts, so whatever you want, and we are relying on that. That's really increased productivity, but why we are struggling? So basically, the struggles come that Java was designed more or less the programming language for long-lived applications. Yeah, just like web containers that take several seconds to start and then leave for weeks, maybe. In microservices world, that has changed. You need now to just that more containers come and go. But basically, the design principle behind all this, all Java, how it's designed, especially applications like Spring, who initially relies on annotations and reflection, dependency injection. It takes time to initialize, and then you are quick. But basically, that's exactly the problem with that cold starts, that the serverless changes the game drastically about this. There are some things also about memory footprint, but let's talk about cold starts. I always hear, we will be talking what is that it's the solved problem. Yeah, many applications are now asynchronously. Maybe it is, but there are requests that needs to be answered quickly in the real time. Like if you log in, it's nothing that can be done asynchronously. Maybe register can be done asynchronously, that you verify your email, but login, it needs to be done fast and in real time, and there are other stuff in the ordering process that you cannot say, I can wait 5 seconds or something like this. Yeah. So basically, because it's not a Java AWS conference, several words about cold start. Basically, it's about Lambda is a function as a service. So the one request can be executed only by one container, and then the container is put back to the pool of containers, similar to the connection in the data source pool. Yeah? So this is kind of there should be enough containers to execute, otherwise there is a need for a new container. And the new container, the start of the new container initialization has its costs. Yeah, it's just work needs to be done. First of all, on AWS, the containers run on this FirecrackerVM, which manages the container. It's not a Kubernetes solution, but from the basic, that's the same. Yeah, it's just managing the container, find the container or execution environment to initialize. And in the case of Java, Java runtime needs to be started on this. Yeah, we selected Java, and Java needs to be started, and then Java runs, loads all this function code from this, the class loading kicks in, static initializer block of the Lambda function needs to be executed, and all that stuff, just-in-time compiler kicks in, all that normal stuff needs to be done, and all this all the steps, all these 3-1 are called cold starts. And only in the end, this execution, warm start, the execution of the function itself is the last point. Yeah, this is where the Lambda invokes the handler. It's only point number 4. And if there is a warm container, then only the warm start will happen. If there is no container available to serve our request, we need to go through all these steps. What is it important is that if you for all programming languages, basically Lambda function, you can only set the amount of memory to the function. The CPU is based on this memory. So for example, you will get the full CPU cycle by 1.8 gigabytes of memory selected. So if you select half of the gigabyte memory, you will get quarter of the CPU cycle. And it's important because in this initializer phase and the cold start, Lambda gives you the whole CPU access for free for 10 seconds. So it's generally more than you will have in the Lambda function. It gives us some optimization opportunity. So maybe once again, coming back here, when this container needs to be initialized. So one example is you deploy the function for the first time. Yeah, there is no container executing it. It just needs to download the code. This is the one example. Or you change the function. It's the same. The old containers needs to be destroyed because you have a new code. Yeah. Another situation is, for example, you have 5 warm containers in the pool, but you now have 6 parallel requests. So 5 containers can serve 5 requests, and you need the 6th one, and then the 6th container needs to be started. And there is also other situation, AWS recycles the container from execution environment from time to time for security purposes. They need to patch the stuff. They don't publish how often it happens, but generally my investigations showed that basically after several hours, even if you have the steady traffic, the container will be recycled. And then there is a need for the new one. So they don't stay for a long time. They patch it, and they also try to decrease the surface of attack, so the one container will not be live forever. So these are the situation. So now, okay, we have cold start time, but what is the impact? So I will show you some demo application of basically we have something in our job, something similar. This is the small software for creating the photo products. We're in the photo product, so create photo product, delete product, update product. You have in front of this API gateway a bunch of Lambda functions, and we store it, first of all, in the DynamoDB. I will be talking also about other possibilities later. So as a start of the investigation, we will use 1 GB of memory. That's kind of a good practice. We will use the default HTTP client. So if you talk to the DynamoDB, this is the HTTP invocation. So that's how you talk to DynamoDB. If you don't change anything, the default is Apache. Yeah, you don't even need to do something. It's by default there. This artifact has 15 megabytes of size, this kind of application, and we will start with the Java compilation options stopped at T at 1. I will be talking about this as was at least the best practice. So this was kind of the experiment for 1 hour where I just called this kind of get product by ID function, 1 hour, and I produced kind of 100 cold requests and 100,000 warm requests during this time. So you see, basically cold start happens maybe 1% of the execution. Yeah, that's roughly it can be different. Yeah, the important thing is that I will be explaining why this have been first 100 cold starts, so after the deployment of the function. Yeah, not simply somewhere I started this, so I redeployed the version so that the new containers needs to be started and all that stuff. So you will be seeing this kind of images for the cold starts and warm starts. I will show you the metrics. So let's start and see at least what we have. Now you see the cold start values. There is no optimization. That's simply is that. No GraalVM first. You see these percentiles. Everybody should know what is that. And you see that the cold start starts with 3 seconds. Yeah, it's only cold start, and you need to add warm start to this because then its execution of the function comes also. And of course, that's one of the reasons, because even if cold start happens only in 1% the cases, not everybody will wait 3.5 seconds for the response. So there are studies that shows that there can be drop-offs if the user wait 1 or 2 seconds. So there is a chance that you will lose users, you will lose money without any changes, I would say. Yeah, so this is kind of, it's a problem. We will also look into this max value of the warm start, which is also a big one. Yeah, so when it happens. But generally, let's start with, now we set the baseline, and let's start about talking about optimizations. Like, there will be some general best practices, but we will be also talking about AWS own technology, SnapStart, GraalVM native image. If we will have time, then about other stuff. So basically, I think general recommendations, it belongs to each best practice in Java. If you can do something in the static initializer block, do it. Yeah, because you are doing it once for the life cycle of the Java class, basically. Yeah, and there are things that really needs to be done. Like if you are talking to DynamoDB, it's an initialization of DynamoDB client. There is no sense to initialize it in the function itself because it will be initialized each time. Yeah, so this is something logical. And once again, in static initializer block, you will have 1 CPU cycle. Yeah, so and then the things will be kind of quicker. So other stuff is sometimes you can initialize each client, SQS, SNS, DynamoDB with default values. But there are some values that requires a bit work on AWS side. For example, in what region do you deploy? Generally, you know. For example, yeah, you know where you host, US East 1 or something like this. You can set it with regions directly. Otherwise, AWS can figure it out, of course, when you deploy, but it can take several 100 milliseconds for them to set it to you and all that stuff. So this is one of the easiest tricks that can be done. Another one is really ugly, but we will benefit a lot later from this. This technique is called priming. And the priming is something that you would like to prime something. You can say pre-initialize, pre-warm. And especially, it requires some knowledge. For example, especially when DynamoDB makes this, if you make the first invocation to the DynamoDB, then behind the scenes, you would like to take something, there is a JSON marshaller active, which transforms your Java object to JSON stored in DynamoDB or then backwards. And this JSON initializer needs time to be initialized. It's the same, it's more or less developed kind of, there is a caching mechanism and all that stuff. It takes some time to be initialized. So it's also sometimes wise to put this logic, some fake invocation, first fake invocation to DynamoDB in static initializer block to preform this JSON marshaller with the full CPU. It's an ugly code because you simply don't know, for example, the ID to get from DynamoDB because it comes with the request, but you can fake it by invocation like get ID 0. You are not interested in the result. You are interested in the preforming of JSON marshaller in this case. Yeah, so if you put this in static initializer block, it can give you some benefits. This technique is called priming, and we will be seeing how to apply it with the AWS SnapStart. But it makes the code a bit ugly. Yeah, just doing some fake invocation just to preform things. And I know I also don't like it personally. Yeah, but if it's about milliseconds, it can help you and give you the choice. You can see. So basically, I will show you lots of other measurements. But word of caution, please remeasure it yourself for your use case. I will explain in the end, when I introduced everything, what are the factors, why you can do the same measurements. You can go to my GitHub account, check it out, and have at least slightly different results. So first of all, now it becomes clear, for example, why is that value so high for warm execution. I did not do any priming during my invocations. I did not prime. And during the first invocation, JSON marshaller needed to be initialized, and the classes needed to be loaded additionally. So not everything was initialized in the static initializer block, and this is something that also influenced the cold start time. So basically, for the cold start time, you need to add one of those values with that max value. Yeah, because it will happen during the cold start that the JSON marshaller will need to be initialized because it hasn't been. It's the first invocation during the cold start, and then you are now nearly 5 seconds of the execution time of the function in case the cold start is happening. And it's just, of course, it's something. So in case priming is possible, but you are not doing it, then the warm execution or the warm start of the execution of the Lambda function may take longer. Yeah, this is something that's important to know. You can get rid of it, but you will see that in the performance. So basically, the best practices are quite known for serverless computing. This is something, reflection, write-time bytecode generation, dynamic class loading. They are not good fit for serverless architectures. And of course, if you have the classical Spring Boot juice, then, yeah, for example, I tried my first Spring Boot application 5 or 6 years ago to deploy it on Java, and I had cold start of 10 seconds. Yeah, and then that's what people try out, and they see, and they say, oh, no, I cannot use it. And it was true that there were not too many solutions back then, but we will be talking about this stuff. So let's start with the AWS SnapStart. Basically, now with the article number 23 about this topic, because you can do it forever, measure for Java 17. But basically, I write on Dev2, if you follow me, a lot about this stuff, and measure and explain how you can reduce it. But what's the promise of AWS SnapStart? It's AWS own technology, so it's not applicable to something else. But what they are doing is they are dividing this life cycle of Lambda function in 2 blocks. Deployment, during the deployment phase, when you deploy the function, and then invocation. And what they offer you, and it's your choice, you can turn it on, you will see on the per Lambda function, they implemented SnapStart is basically Firecracker micro VM, the whole execution environment, snapshot creation, and restore. So the whole snapshot will be restored, the whole VM, where JVM is only part of it, but the whole VM with the operating system is snapshotted in the deployment phase. So it doesn't impact the invocations of the function, but it impacts the duration of the deployment. We will be talking about this. And then during the invocation phase, there will be the restore phase of this, yeah? If you enable this. We have here also hooks. We will be talking about this, what they bring, these hooks, optional hooks. But basically, what's the promise? Yeah, why it should reduce cold start? The promise is, or at least what it should solve, is that the restore phase of the whole micro VM will be quicker then the cold start. Otherwise, it just doesn't make any sense to activate. Yeah, so this is what AWS was experimenting. They released it in December 2 years ago, so 1.5 years ago, basically. And this is kind of, they try it out and just to figure out, will it be quicker than these 3 seconds that we see? And we will see, will it be quicker or not. So basically, it's your decision. You simply go into the function configuration and say here, SnapStart, yes. That's basically it. Yeah, and then everything will happen. You will see when you deploy, we will look into the logs, you will see what will happen. But basically what happens around the corner, then this Firecracker snapshot is taken. It will be stored, encrypted and stored in low-tiered cache. It's important. I will be talking about this in the kind of in multi-regional fashion, like AWS does it. You just, in case one region is going down, you have the cache in not region availability zone is down, and you have it on the others. That's why it's also a bit taking time. But basically, this is it, and then you're doing request, and it's resume operation, so the snapshot will be restored. Who of you heard about CRIO and CRaC in the Java world? Are there any people? So at least, yeah. We do not need to interchange the stuff. These are similar things, but basically just to give you an overview, CRIO is basically to move containers from one system to another. It's in the Linux space since 12 years. This is technologies that has its own challenges with open files, network connection, time-based caches, and all that stuff. So how it relates to Firecracker micro VM snapshot, SnapStart. So there are differences. So Firecracker snapshots kind of the whole running operating system, while CRIO is snapshotting only one process. Yeah, that's the difference. So Firecracker does it differently. It has advantages because in case of SnapStart, you are not caring about file handles that are open and all that stuff, but it has its drawbacks also in sense that you need to reset time and sync the system clock. In both situations, time-based caches cannot be used. For example, if you store something for 10 hours, and then they resume going 11 hours later, then you don't have a value. So you need to think what's not usable. So time-based caches probably is one of the things. So once again, if you activate this, you will be seeing the following. In case you are doing deployment of the function, whatever it is, CloudFormation, SAM, you will be see here init start. This is then the snapshot basically takes place, and you will see here some values, how long did it take. And in case you have SnapStart enabled and you execute the function, Lambda function, you will be seeing something like restore report. This is the sign that the snapshot has been restored, and you are using SnapStart basically. Otherwise, you will not see something like this. You will also see restore duration values and all that stuff. We will be looking into that. So now, another concept, some people raise their hands about CRaC. So it's important to know, so first of all, CRaC is something similar, but on the Java space, so coordinated restore, so how to snapshot the JVM itself, yeah, based on the CRIO. Yeah, this is done by, that's now also very popular technique to do outside of AWS. Spring supports it natively, but you need CRaC via JVM. For example, normal Oracle is not. You need other companies produce these JVMs. But basically, SnapStart doesn't use CRaC. What SnapStart does, it uses CRaC's APIs for these optional snapshots. Before snapshot is created, there is a hook, and after snapshot is restored, there is an optional hook. They use only the APIs. Why, I don't know, because the people then interchange, but it's simply APIs, and we will be looking into this. Yeah, this was also the promise of CRaC is the similar. So the time for the first operation is quick because JVM can be restored quickly, but AWS SnapStart is just restoring the whole operating system, including then JVM. So now just let's see what we can do with this, especially with these optional hooks. Yeah, they implement the CRaC API, so you need to import this org CRaC, and then you need to implement the resource interface. Yeah, then you need to register, this is the Lambda function, get product by ID. You need to register this Lambda function as a CRaC resource. That's basically the same line in the constructor. Register this as a class. And then you have these hooks before checkpoint, before the snapshot is taken and after restore. I basically don't do anything in the after restore, but before checkpoint is a very good place if you know something to prime, like DynamoDB invocation with priming HTTP stuff and all this Jackson marshaller, then it's a good place to prime it. Why? Because priming before checkpoint is called during the deployment phase, before the snapshot is taken, so the user is even not impacted. It impacts maybe the duration of how long it takes to take the snapshot, but it doesn't impact then the restore and all that phase. So this priming becomes even more, it's still the ugly code. You need to do something product, get product by D0, and I'm not interested in the result. I'm interested in the prewarming, the marshaller, loading the classes down the chain so that the snapshot contains more and more useful things. And this is very important stuff. So basically, AWS now published the SnapStart guide, so you can look into how to do it more or less on the efficient way. There are other things, not only DynamoDB, which is known, so you can read through how to do it with less effort. I personally hope that there will be libraries that are doing it behind the scenes, because it's always the same in the situation what you are doing, and it's just repetitive code, but we are not quite there. I also recommend you the talk AWS Lambda Under the Hood from the AWS principal engineer Mark Danilov on the KubeCon, who is going much deeper into the details how SnapStart works itself. It's just, I have lack of time, but he explains how this tiered caching works and all that stuff, really interesting. So SnapStart has its limitations. AWS advertises it for each, they don't say AWS SnapStart for Java, but currently only supports Java, which is good. We are talking about Java, but generally the net will, C#, they will have the same problems, and maybe that could be for them also. So deployment of the SnapStart, in case you enable SnapStart, the deployment of the one Lambda function takes between 2 and 2.5 minutes. Because this taking of the snapshot and then storing it in individual zones, it takes time. So this impacts the experience. It takes 2.5 minutes to deploy one function. If you deploy in one package many functions, then it's happening in parallel for the function. So if you have 10 of them, you will have the same duration, basically. So there are some caveats. So for example, this snapshot will be deleted if your function isn't invoked for 2 weeks. So think of what function is it, especially if you're on the staging environment, don't do anything there, and you activated SnapStart, the cache will be deleted, and the first invocation will lead to the error, or not the first one. The first one will kick in the snapshot creation, and until it's not created, it will be an error. Not a pleasant behavior. I reported this, that there are other stuff to do, but basically, if you have hot Lambda function, you are not impacted. And SnapStart doesn't currently support provision concurrency. ARM architecture, in case you're using elastic file system, it's also not supported, but we are basically storing things on S3. So there are things that I also recommended AWS, like a feedback that in case the snapshot is not found, that they don't throw the error, but have the regular cold start instead. And then the snapshot is created, then they can switch to SnapStart back without me, because I totally understand that they delete the cache, because cache costs money. If you don't invoke the function, then why they should keep it forever? They help you as long as you are benefiting from this. So let's see. I'm working quite tightly with developer advocates, doing that stuff, giving the feedback. So basically, we talk about this. We would like to see numbers. What does this SnapStart improves? So now you see the same things, gigabyte memory, HTTP, Apache HTTP client, this tiered compilation we'll be talking. These are the values that I gave you basically last time. Without SnapStart, now this is the SnapStart, but without priming. I didn't do priming. And you see, it holds its promise. It reduces the cold start time. Now you see, basically, I always like this yellow one because it's P90. It's something that gives you orientation. Now you have here 3.5 seconds. Now you have here 2 seconds. Only by enabling SnapStart and doing nothing. If you have priming, and in case of DynamoDB, no, it works, and you implement these hooks with before checkpoint and do what I showed you, you can, for P90, you can go 1.5 seconds or 1.3 seconds. So it's from 3.5 to 1.3, and it's a huge improvement, to be honest. Yeah, it's really a huge improvement from 3. You just bringing it 60%, 70% down. Yeah, and for P50 you will have even better values, and there will be caching behavior we'll be talking about. Also, now looking to the worm start times, not really a big difference. So the snap start priming is just the technique to reduce the cold start time. So there is no impact on the warm start. It's just, but basically also measured, everything is working. These are P99 and max values, everything's fine. So now we started like this. Let's now move forward and then see what we can change and how it impacts the cold and warm start times. So I simply did the measurements with different memory settings just to see what it will bring. Yeah, you can give Lambda something between 128 until 10 gigabytes, but it's also cost factor. So this is the measurements without SnapStart for this use case. First, without SnapStart, and you see you have somewhere here sweet spot. 1 gigabyte is kind of very good memory setting anyway. Yeah, so basically doesn't make any sense to increase memory because you will pay more and the cold start remains more or less the same. And the same you will be seeing here also for the warm start time, it's basically the same. So with 1 gigabyte, you're also good to go without SnapStart, and similarly also with SnapStart without priming. So not a big, so after this 1 gigabyte, you don't see an increase. And basically, it's the same for warm start time. So SnapStart without priming. So all my investigations, at least for this use case, show that somewhere around 1 gigabytes, it's a very good setting. It's more interesting and more interesting result if you have SnapStart and priming. You see that even having 768 megabytes, the results will become closer. Yeah, so SnapStarts enable, with SnapStart and priming, you can think of maybe giving a bit less memory, which is of course factor, and have also the good results. So also the warm start times, yeah, they are comparable. So if you have SnapStart and priming, you have much tired result. You don't have these max values going so high because everything is pre-warmed with SnapStart and priming in the cache. So you don't have these huge max values as well. That's a huge benefit. So basically check it out, try for your use case. I also try to figure out, does the deployment size matters in case especially SnapStart is enabled? It's known that if in normal case, of course, the bigger the package size is, the longer the cold start, because this whole thing needs to be downloaded, initialized, more code, and all this stuff. But I thought, if I activate SnapStart, will it matter? Yeah, because yeah, the restore phase, how it depends on the size. And it still depends. So I just tested something hello world. Nobody is writing, but it's several kilobytes, 15 megabytes, and 50 megabytes of Lambda functions. And also what you see is that the bigger packages have bigger cold starts, also with SnapStart and also with priming. So it's still true that you need to think what you are packaging. Yeah, so don't try to package only what you are using. Don't package any JUnit test in the live application. So it still matters. Sometimes if you have Tomcat or long-lived application, we package so many things we don't even ask. It just don't bother us. It just starts and it works. But with Lambda, it just each kilobyte matter. Yeah, so this is still true. These have been the last things this is the first time I present this. There is another possibility to package using Lambda layers. With Lambda layers, if you have all your Lambdas have the same dependencies, and in my case, they are all the same. Yeah, I have this Java core events, Jackson, logging, CRaC, all that stuff. There is a possibility to release this as a package in the Lambda layer, and then simply use this Lambda layer. It reduces the package, the size of the Lambda function that I deploy. So I deploy only the layer, and then I reference the layer that you see in the Lambda function. I publish this layer with the dependencies, and I wanted just to figure out, will it be the difference using Lambda layer and not using Lambda layer? I need to dig deeper, but for example, I only published here P90, yeah, for the use case in cold starts. You see using Lambda layer, at least increased a bit cold starts. In case I had priming, the difference wasn't big because everything was in the snapshot. Yeah, it was initialized. But this seems to be mattering, and this is the warm start for P90 also. So very interesting situation. So I probably will jump over Java compilation, but basically you can use tiered compilation or they stop at level 1. They produce the better results. You can then look into the slides. I would like now to talk about just selecting, for example, other HTTP client. We said that the default one is Apache. You don't need to do anything, but generally, if you build the client, all clients, SKS, SNS, just doesn't matter. You nearly always have the possibility to set HTTP client. And for example, if we are programming synchronously, you have two other options, URL connection HTTP client, and the AWS owns AWS CRT HTTP client. Of course, you need then just to add this as a dependency. And this is HTTP, AWS HTTP client was released because this Apache thing is working like for long-living environments. It initializes caches and all that stuff. It's not designed to work with serverless environments, and it takes time. The same as URL connection. So basically what you can see here, this AWS CRT HTTP client produces the lower cold starts. Here you see without SnapStart, with SnapStart, without priming, and with priming. So it's, yeah, it really uses the stuff, especially if you have priming, then it's the same stuff, because we initialize the client during the priming, and it's in the snapshot, you will not see the results. But especially if you don't have something to prime, yeah, you don't see anything that you can improve, this AWS CRT is a good choice. And it's, once again, one of these examples that AWS is actively contributing with SnapStart, with this HTTP client, which is designed for serverless application. Basically, the same you will be having for the warm start times. It produces quite the best results possible. You have the possibility to program asynchronously. It's the whole other topic, would you want to do it or not, but there is a possibility, for example, to design, to create an asynchronous DynamoDB client, and then you have to pass asynchronous HTTP client. The default one, if you are not doing anything, is Neo. It's just simply there. But this AWS CRT client has also asynchronous possibilities. So you can use it for synchronous and asynchronous programming. The same stuff. Of course, then if you are asking, just get the item from DynamoDB or doing anything else, you will not receive the result, but completable future, asynchronous style. Yeah, and then you need to think, would you like to join in Lambda function or stream it to the front end? In another sort of things, of course, you need to add it as a dependency, but once again, this green one, as AWS CR3 asynchronous client, outperforms native Neo by far, especially in both situations, without priming and without SnapStart enabled, and with enabled and priming. Once again, close result if you have priming, because everything is primed in the snapshot. And the same is even for the warm start. Yeah, it outperforms. But of course, it's the choice of AWS of HTTP client is much bigger, because, for example, Apache gives you much more possibilities to deal with connections, with caching. I only tried default ones without setting anything. So AWS released more or less even kind of mind map, how you can navigate and choose what's the best one is. And of course, the programming asynchronously is something completely different. Yeah, you may not want to do it because it introduces a whole lot of other challenges. So I talked about this stuff, low tiered cache, that the things are stored and loaded in this low latency cache. And the thing is that I told you I measured the first 100 call starts. So the cache was empty, basically. It's the first invocation, and of course there is no cache. But what I saw, and AWS describes it, that with each call start, the results are getting better with more invocations, because the cache is filling and only parts will be replaced. If the cache is empty, then you have the worst results. And this is exactly it. So I tested here a bit. This is the result for the first 100 invocations. And this is the result, and I only took the last 50 of them. So the first 50 I omitted. So I just already had 550 cold starts, and from then on, I started to measure it. So you see here, SnapStart without priming, and here SnapStart without priming, last 50. So you see that it's going down. So basically, and the same is here, yeah? If you have priming, the first 100, and here this is kind of the last 550 from this first 100. So you see that you are getting better results. And that's important because in the beginning you can say, okay, these are quite high values that you are still showing, but in the end, after several slower invocations, even with AWS SnapStart, you are getting better results. So the last 50, you are seeing that P90 is below 1 second with priming, yeah? And here, it's still a bit lower than 2 seconds. So if you have priming, then you can go down below 100 milliseconds. So my investigation showed that you will have the consistent best performance more or less after 50 cold starts. Then the cache is more or less there. And I also tested them the next day to see what parts of the cache can be removed. I had still very good results. So don't be discouraged if you measure something with SnapStart and see bigger results. Continue measuring. You will see this improvement of this cache. So we have 8 minutes of time. I just wanted only to briefly talk about GraalVM native image. I think everybody should know what it is, and the most important thing is this GraalVM compiler. Yeah, this is ahead of time compiler, what we are interested in, because with ahead of time compiler, you pre-compile everything together. Yeah, so what you are requiring, reachable methods, fields, and classes, and then you provide the meshing, the binary of operating system, and GraalVM supports all operating systems. It gives you the choice, ROT or just-in-time compiler, but it's known that the ahead-of-time compilation is optimized for start speed, low memory footprint, and small packaging, which are the properties of the serverless. Yeah, so it's worth exploring, and of course, it can reduce the cold start time because it's only there what's required, and the second thing, it reduces memory footprint because it's precompiled for your native use case. The situation is AWS doesn't provide any GraalVM managed native image, so there is nothing to choose, but what they do, they provide custom runtime as a deployment option of the Lambda function. And with that, what you can do is to package the zip that you need to provide with a file basically named Bootstrap, and if you produce the GraalVM native image and name it to Bootstrap, you can deploy it, and then the GraalVM native image becomes more or less active. Now we see that GraalVM release changed. So previously they supported long-term releases, but now they support each release. So if you see OpenJDK release, they release as well. And they contributed now to the community, so there is no enterprise edition. So basically, GraalVM cycle is married to OpenJDK cycle. So now let's see what GraalVM gives us, the GraalVM native image for the cold start. This is what I added, GraalVM native image performance. Yeah, you see half of the second, by far the best results, but please remember here the caching also will take place, so you will have here lower results after the 15 invocation. But basically, if it's only about the lowering cold start as much as possible, GraalVM native image produces the best result. And here is the warm starts with GraalVM native image, also sometimes lower, but they are comparable. We are talking about milliseconds here, but the maximal values here, this P99 and max, are also very low with GraalVM, so you don't have these outliers that are huge. I also tested one more thing with GraalVM, just giving different memory settings. And it's only the cold start for GraalVM, and just you see, first of all, tested with 1 GB, but you see you have comparable results with lower memory, and it's the cost factor. So you can go with GraalVM native image with lower memory and save cost. So these are the warm starts, also very comparable for lower memory. And this is also the max values of them, P99.9 max values, so you can go with that as well. Basically, yeah, this is more or less my conclusion. GraalVM is really powerful. Yeah, it's for free in terms of doesn't cost you, simply just can use GraalVM. But it has challenges. For example, AWS Lambda runtime requires only Linux executables. Yeah, GraalVM supports Mac and Windows, but in order to deploy it on AWS, you need to produce Linux executables, so the people having Windows and Mac cannot do it on the local machines. And of course, it's about, you will probably have heavy load on your CI/CD stuff, because it requires 6 to 10 gigabytes of memory to build native image. And you have sometimes many functions in parallel that needs to be built as a native image. So it's then about how to scale CI/CD. You can use managed service, and then it will be scaled for you, but it will be a factor of cost to build that. SnapStart is for free. You just simply activate an AWS to create the snapshots on your own. It's the managed thing. Here, it's up to you how to do this. Build time is a factor. I had the same 2.5 minutes for building native image for the same application, so they are comparable to deployment time of the SnapStart, which contains creating the snapshot. So taking the image takes more or less the same. Yeah. Also, you will need to pay for a init phase. It's for free for managed Java, and AWS Lambda custom runtime isn't, but it's not a huge price that you will pay. Of course, you need to pay attention to reflection with GraalVM, because it's ahead of time compilation. You need to put everything that it's required. Otherwise, this leads to the error in runtime if you don't put things together. But especially using Lambdas, there is a lot of reflection happening. For example, the Lambda function itself will be initialized per reflection, and your entities, like here, the product also. So you basically need to generate this JSON file and put everything there. Yeah, it's mainly repetitive operation. They may be small, but things. But that's an additional job, especially first time if you do it to figure out what you need to put. Yeah, a bit mental load. And of course, you need to look. Your application should be the whole GraalVM native capable. And sometimes we use other frameworks like Spring and all that stuff. And there is this page that the GraalVM people publish what has been tested, that there are no reflection or other effects. So basically, 4 major frameworks are safe. They are battle tested, yeah, with all dependencies. But sometimes you use some other open source dependencies on your own, and there is no guarantee, you don't control it. In that version, it may work, and then in another version, they add some reflection, and then GraalVM stops working. You need then to think what to put and all that stuff. So they have the version, but it's kind of, you need to test. You need to test it that you don't run into the runtime issues. It's not for free as well. Yeah, so basically, this is, we can maybe jump over this. This is basically what I wanted to tell you. I am currently now writing another article series about, there are 5 or 6 ways how you can deploy Spring Boot 3 application in AWS Lambda, so that the cold starts won't bite you. I'm currently, I think, the 7th part of this, and it will continue probably for several more. So this is another way, and then I will do the same for Micronaut and Quarkus, because they increase the productivity. So this is exactly Spring Boot series. There is also another series about using data API in case you don't use DynamoDB, but you use, for example, Aurora Serverless, so a relational serverless database. You can talk now with data API to it, but you have the same issues, the cold start and so on. So these are basically 2 articles that I'm publishing. So maybe why, once again, you need to remeasure it. For example, I tested, that's a managed Java version, Java 21. I tested this in the course of the several months, but the minor versions changes. AWS patches that. So there can be some changes on the Java ecosystem, and you have a bit different results. So just, if you will now measure, it will be another minor version. Snapshot create and restore can also have improvements. Yeah, AWS improves this behind the scenes. We can have better cold start times because the restore is quite quicker. There can be FirecrackerVM improvements, GraalVM also improvements. I tested with GraalVM 21. There is now GraalVM 22 because there is a Java 22. So there are things that can be, there are still servers behind Lambda. Yeah, so there can be some outliers, and there is also Java memory model, impact, L caches, RAM, and all this stuff. So there can be some changes if you will retest and see some different results. I don't expect them to be huge, but there may be improvements also there. But I wanted to give you some direction. What are the influence factors? So I personally, if you would like now to compare SnapStart and GraalVM, I personally prefer the easiest possible solution, that it's SnapStart, in case I can prime. Yeah, because it's checkbox. Yeah, I don't need to think of reflection, CI/CD stuff, but if it's, and I can take into account 200 milliseconds more of the cold start. I'm willing to have that for the simplicity. In case it's about milliseconds for you, it's very important, then of course check out GraalVM native image. It's an amazing piece of technology, nothing against it, but I'm really a huge fan of kind of managed stuff just to offload this complexity. But everything improves on both sides, and it's good to have a choice, and that's basically it. So you see, you can now have this normal cold start time, something beyond 1 second, and it happens only in 1% of the cases. So I think it's worth doing now, yeah. And Java has a bright future, and there are also changes on the Java platform itself. Project Laden, the Java itself, how the things are going underneath, should be a bit adopted towards serverless, but it will take years, I think. Yeah, but we will see improvements in all possible areas. Thank you very much.